Hi, welcome back to this continuing Quick Start series on the Aruba CX platforms. In this episode, I'm going to dive a little bit deeper into the CX 6300 switch series. So let's go ahead and jump right in. So I wanted to start off by reminding everybody that the Aruba CX 6300 switch series is actually built using our own in-house Generation 7 ASIC. This is an ASIC architecture which was actually built on over 30 years of intellectual property here at Hewlett-Packard. With this architecture, we're able to actually deliver more innovation and faster innovation to our customers, in that we literally have the software teams and the hardware teams sitting side by side working together to deliver this integration. We've built in high-performance capabilities into these ASICs, which include virtual output queuing. So this is really a capability which helps prevent head-of-line blocking and optimize traffic flow throughout a network. This is a capability that you often see in data center switches, but of course we've built it into the Aruba CX switches, the CX 6400 for example, and the 6300. And then lastly, our ASICs actually support flexible programmability, which is something that we utilize here at Aruba to help enable all of these different use cases from campus all the way to the data center. So depending on the deployment model and the use case in your environment, we're able to dynamically adjust and program our ASIC to suit that use case. And as a refresher for the first episode on the 6300 is a series of switches. There's actually 11 switches in this series, 7 modular switches and 4 fixed switches. And they all, of course, operate with one operating system, the Aruba CX operating system. They can scale to upwards of 880 gig of capacity, and they can stack in upwards of 10 members into a single stack. And they have options for offering high PoE power, so 60 watts of PoE, upwards of 2,880 watts of available PoE power. We have a number of different models that come in 1 and 10 gig versions, as well as the versions also have 25 and 50 gig uplinks. Now let's look a little bit closer at the switches themselves. So we have the modular switches on the top and the fixed switches on the bottom. Let's start with the fixed switches on the bottom. So on the bottom two, we actually have our 24 port and 48 port 1 gig and 4 ports of SFP56. So this will support 10 gig, 25 gig, or 50 gig. So you'll see on the right, all of these switches come with 4 embedded SFP56 ports for uplinks. The bottom 2 switches are our non-PoE switches, 24 port and 48 port 1 gig. And then above them we have our PoE switches. So these are class 4 PoE switches, 24 port and 48 port. And of course these are the fixed switches, so the fans and the modular power supply is fixed embedded into the back of these switches. But if you wanted a higher level of redundancy, you could go with the modular versions, which are on the top here, in which you can actually install a second power supply and a second fan tray. Starting again at the bottom, we have our 24 port 1 gig and our 48 port 1 gig non-PoE models. Of course they still have the 4 SFP56 uplinks. And then right above them we have the class 4 PoE models. So again, a 24 port 1 gig and a 48 port 1 gig, each again with the SFP56 uplinks. And then right above those we have our class 6 smart rate models, which support 24 ports of 1, 2.5, and 5 gigabit smart rate ports that can support class 6 PoE. And then we have a 48 port model that can support 1, 2.5, 5 gig class 6 PoE ports also. And then finally at the very top we have a 24 port SFP Plus aggregator switch, and this one also again includes the 4 SFP56 uplink ports. You'll notice the fan trays, the top 2 switches actually include 2 fan trays, so these require 2 fan trays, and the remaining switches include a single fan tray, but we can add another one for redundancy and of course power supply also. Here we have a slide showing what I just mentioned. So the 6300 modular switches, they only require a minimum of 1 power supply, but you could add a second one for redundancy. And they also only require a minimum of 1 fan tray. However, those 2 SKUs at the very top on that last slide are the 2 that actually do require a second fan tray. And then of course the fixed switches, the power supply and the fan trays are embedded. If we want to look at the PoE budget on our switches, so with the modular switches we have a few different PoE power supplies that you could choose. A 250 watt, a 680 watt, a 1050 watt, and a 1600 watt. So depending on the type of power supply that you choose, you'll have different levels of available PoE power. And of course, depending on the mode that you want to operate that PoE power in, redundant mode, which would be the same thing as if we were operating on a single power supply, or non-redundant mode, where we're actually consuming all of the PoE which is being provided by both of those power supplies. And so you can see, depending on the power supply that you chose, we can scale from closets that may require just 300 watts of redundant PoE, all the way up to closets that may require 2,880 watts of non-redundant mode PoE. Now if we look at the very bottom, we'll see our fixed switches. So these are the ones that have the internal power supply embedded into the switch. So the 48-port model can scale to 740 watts of PoE, and the 24-port model can scale to 370 watts of PoE. Now let's take a look at the front panel of the 6300s. So on the front panel of the 6300s, we have a number of LED indicators which can provide a lot of information that can be useful to administrators. So we have a back indicator, which is an indicator telling the user on the modular switches that there's a component on the back of the switch, and this is indicating something on the back of the switch. The PoE indicator, of course, is indicating PoE status information. The speed indicator will show us port speed information on the front panel ports. And then we have a stacking indicator too, which will show us a health indication of the stacking environment, as well as a unit identifier. We have a global status indicator, which will show the health of the overall product. And then of course, our out-of-band management status LED indicator on the management port. Now some other front panel buttons that we should look at are the reset button and the LED mode select button. So the reset button is a quick and easy way to reset the switch when you have physical access to the switch. So you can press it and you can hold it for more than 5 seconds to generate a hardware reset. Or you can press it and release it within 5 seconds to generate a software reset, which will allow the switch to complete all tasks and then perform a simple software reset. Then we also have the LED mode button, where we can toggle the LEDs on the front panel between the link mode, which is the default, to the PoE mode, or the speed mode, or of course the stacking mode. Taking a look at the back of the modular 6300, since these are the modular ones, we can see the 2 fan trays and the 2 power supplies that have been installed. We have an indicator showing us the health of these, of course. So we have a fan health status indicator, a power supply unit indicator, and of course a unit identifier also. So as far as what's included in the box or what's orderable, the box is actually going to include an accessory kit as well as a Bluetooth dongle. So the accessory kit will have a mounting bracket with the screws and will have some rubber feet. And the Bluetooth dongle is actually a Bluetooth dongle that allows administrators to configure the switch via Bluetooth using their phone or their tablet. Some optional orderable options are a USB-C to USB-A console cable, as well as a 2-post rack kit if you wanted to actually post it and mount it into a 2-post rack using a center mount. I hope that was helpful information on the 6300. Stay tuned for some more videos on the Quick Start series, and have a great day.